Hello everyone, welcome to lesson 717. Today we're going to be talking about the tangent function. So we have talked about sine, we've talked about cosine, and when we've done that in the past, what we did was we went around the unit circle in increments of 15 degrees, and we built tables, right, for each of those positions on the unit circle. So once we built that table, then we used that to create a graph. We're not going to do it that way this time for tangent function, just because we don't have the time to spend 2 days just building the table and the graph. So instead what I'm going to do is I'm just going to show you what the tangent function looks like on the graph, point out some of the key features, and then show you why those key features happened, and also then use the unit circle to help us find like exact solutions when we deal with the tangent. All right, so our goals are pretty much the same as before. We want to use the unit circle to solve problems, and then we also want to use the unit circle to find exact solutions, this time specifically for tangent. All right, so let's get right to it here. I'm going to go ahead and just show you the graph here. This is the tangent graph. This is what it looks like. It is a weird looking function. The function itself are these gold colored lines that we see. They almost look like a cubic function, but not quite. And then these dashed lines that are in between these wavy looking lines here, these are called asymptotes. You might remember these. We saw these back in first semester. This is an asymptote. And the tangent function has asymptotes, many of them, right? And it is still a periodic function because the tangent function repeats itself. You see this wave, it repeats itself again over here and then again over here, and it would keep on going forever and ever as we rotate around the circle, okay? So we kind of see the key features here. We see that it's periodic, right? We see the asymptotes, and then we see the specific shape, all right? So real quick, I want to show you how do we get a value here on the tangent graph, or what causes these asymptotes to occur in the graph. So if you recall, last semester we talked about asymptotes occurring whenever the function is undefined, and tangent has special points where it is undefined. All right, so let's do this one here. We're gonna take a look at pi over 2 or 90 degrees. There's clearly an asymptote there at 90 degrees. So if I'm looking at 90 degrees, here's my 90 degree position on the unit circle. So we go back to geometry and we say, okay, well, the definition of tangent is opposite over adjacent, right? If we're thinking about SOHCAHTOA, right? TOA, T, opposite over adjacent. Well, in our unit circle over here, if we're looking at opposite and adjacent, we know that the side opposite, like if I were looking at this angle here, right? And we said, okay, hey, here's a 30 degree angle. The side opposite would be this side, which is the height, and the side adjacent would be this side down here, which is the horizontal distance, right? So opposite and adjacent kind of turn into height and horizontal distance, and we know we can find the height using sine, and we know that we can find the horizontal distance using cosine. And then we also know that it's synonymous with y and x, right? So when I look at these two coordinates, this is sine, the 1 is the sine, and the 0 is the cosine, right? So this is x and y. So we can say the tangent of 90 degrees is equal to y over x. So when I go to 90 degrees and I look at this coordinate, the y value is 1, and the x coordinate is 0. And we start to see the problem here, because if I do 1 divided by 0, well, that's an undefined value, right? If I pulled up my calculator and I tried to do 1 divided by 0, you would get an error. That's because you cannot divide by 0. It's impossible, all right? So we get an undefined result. And when that happens, we get asymptotes. And we can see that happens here at pi over 2, then again at 3 pi over 2, or 90 and 270. And if we went the other direction, negative 90, negative 270, so forth and so on. All right, so this is why we get those asymptotes in the graph. All right, so that's all I really wanted to show you about the graph for tangent, and I think we kind of get the idea of how to calculate tangent. But let's actually go and do some calculations for tangent, because we want to know how to get exact values when we talk about the tangent function, right? So how do I calculate exact values of tangent like we did with sine or cosine? All right, so let's recall, right? Cosine finds the horizontal distance, sine finds the height, and tangent finds what we would call the slope, right? And it kind of makes sense because tangent finding slope, because we have a rise and we have a run, and it's rise over run, right? Opposite over adjacent, y over x, right? All those things. So these are the three major things that each function finds. They each have their use. So you can kind of see like why we would want to find tangent. If we wanted to know the slope of a line, we could use tangent to do that. Right? So when we talk about tangent of 30 degrees, right, we have to kind of visualize this triangle that's on the unit circle. So here's my triangle. And we would say, okay, here's our 30-degree angle. We know this is 1 if it's on a unit circle. And then I'd go up here to my unit circle and say, okay, well, at 30 degrees, we have the height being 1/2. And the side adjacent, right, over here is √3/2. This is my horizontal distance. And if I'm doing tangent, we would want to do opposite over adjacent. So we'd say the tangent of 30 equals 1/2 divided by √3/2. Okay, so this is the setup to do the tangent calculation, and you're probably sitting here thinking like, man, that looks like one mean fraction. How are we supposed to deal with that? So let me show you. Whenever we divide two fractions, so you notice how we have a fraction in the top and we have a fraction in the bottom. When we divide two fractions, we use a mnemonic called KFC. Right? It's keep, flip, change. So we're going to keep the top. Right? So I'm just going to say equals here, and I'm going to say here's the top. I'm going to flip the second one. So I'm going to say 2 over √3. So I took this bottom fraction and I flipped it, and then we're going to change from division to multiplication. Okay, so keep the first, flip the second, change to multiplication. And then we just simplify things, right? I have a 2 in the top and a 2 in the bottom, so the 2's cancel each other out. They become 1's, and then we multiply straight across. 1 times 1 is 1, and 1 times √3 is √3. There's the exact value of tangent. All right? That's how you do it. That's how we're going to do it for the rest of these. But I'm going to make it even easier. You don't even need to draw the triangle on these. All right, guys? So, for instance, let's do the tangent of 3 pi over 4. All right, so I'm going to go up here. I'm going to look at 3 pi over 4. So 3 pi over 4 is right here. So here's my coordinates. Here's x. Here's y. We already have that filled in from our unit circle. So remember, we're doing y over x, right, to calculate a tangent. So I'm going to say √2/2 divided by √2/2. Okay, so I'm going to set this up. Keep the top, right? So √2/2. Flip the second, so 2/√2. Right? Just flip that second one, and this is negative, right? So this one is the negative one, and then change the multiplication. All right, so we've got it set up. Now look for things that cancel. So the 2's will cancel. Right? -2 divided by 2 is going to cancel out to be -1, and then √2 divided by √2 is also 1, so those cancel out. So this whole thing just ends up being -1. There's our exact answer. Okay? So we would say the tangent of 3 pi over 4 equals -1. And don't get thrown off by the 3 pi over 4. That's just a radian measure. All right, so it's just an angle, just like 30 degrees was. It's just in radian form. All right, let's do one more here. We're going to do the tangent of 240. So I'm going to go up to my unit circle. I'm going to find 240. Here it is. And here's my coordinates. So here's x, here's y. We're going to do y divided by x. Keep in your mind that they are both negative. Okay, so we're going to do -√3/2 divided by -1/2. Okay. So again, I'm going to set this up. I'm going to keep the top, so -√3/2. And we're going to flip the second one, so we're going to say 2/1, and that's going to be negative. And then we change the multiplication. Okay. 2's cancel. So we got -3 times -1, or I'm sorry, -√3 times -1, so that's going to become a positive √3. And then 1 times 1 is just 1, so we got √3/1, which equals √3. And there's our exact answer. All right, guys. So just to kind of recap here, we talked about the definition of tangent, Up here we talked about its definition. We used the definition to kind of explain why we got asymptotes in our graph, right? Because that was one of the key features of the tangent graph. We also saw that the tangent function is periodic or cyclic like the other functions, sine and cosine. It just repeats itself over and over again. We now know what the shape of the graph looks like, so we should be able to tell a tangent graph apart from sine and cosine, no problem. And then we learned how to do calculations to get the exact values of tangent. Alright guys, that's it for today's video. Give the practice problems a try and let me know if you have any questions in the Zoom chat. Have a great day.